Hello, in this lecture video, I am going to be talking about, in this case, unit conversions between English to English or English to metric unit conversions. However, this technique is also useful in doing any simple mathematical calculations for this class of chemistry. Just to give you an FYI, only the units and common units that you know, like how many seconds there are in a minute, so on and so forth, will be used. And this is in page 7 of your exam reference sheet. I will not trick you by asking you a question that requires you to know units that is outside of those units. For significant figures, so anytime we do math now, we have to consider significant figures. Note that all of the numbers in your exam reference sheet and the periodic table and the number one are exact measurements, and so they do not play a role in defining how many significant figures your answers actually need. Okay, so here's an example. All numbers in your sheet, anything that has an equal sign across from each other, can be expressed as two different ratios. In your page, in page 7 again, in the length conversions, it tells you that in 1 yard there is 3 feet, or 3 feet in 1 yard. All of those factors, all of those relationships, any relationship period, can be expressed as two different ratios. 12 dozen in 12 eggs in 1 dozen of eggs, or 1 dozen over 12 eggs is the same. Now, why do we need to express this as two different ratios? Because the ratio that we use is dependent upon what is getting calculated. So a couple of examples is going to be appearing shortly. So in here, we are converting, it says convert 12 yards to feet. And we're using these two examples here. And as we can see, the way that you decide which ratio to use is you need to use the ratio in which the given yards is on the denominator, and the unit that you need, feet, is on top. So between these two, as you can see, this is the ratio that you need to use, because again, the feet, that unit that you need, is on top, and the unit that is given is on the bottom. And in this case, all of this conversions is multiplications and division. So you do 12 times 3 divided by 1. And as you can see, what happens is the yards is on top here. All right, and the yard is in the denominator here. And what happens with those units, folks, is they cancel. And when they cancel, you are just left with the unit feet. Okay, this is why this technique is sometimes referred to as unit cancellation method. And you can do this with any problem. As long as you know how to set up units and set up relationships, you can cancel the units that you do not want, and you can come up with the units that you need. Another example, how do we use the other ratio? Here, it's converting 48 feet into yards. So again, we are selecting which of those two ratios we need to use. And as we can see, this is the ratio that we need to use, because the yard, the unit that we want, is on top, and the unit that is given. And how do you know which unit is given? The unit that's given is always follows the number. 48 feet, that's given. So then the feet goes on the bottom. We do the math. 48 times 1 divided by 3, 16 yards. For your information, we are still using significant figures. There's two significant figures here. There's two significant figures in the answer. We do not consider the ratio in the exam reference sheet into determining significant figures. Two significant figures for answers. A couple of other examples here from doing math. Conversion of 23.6 feet to miles. If you look at your length to, like in this case, length conversions again, how do we know which we need to use? Well, in your table, there's this relationship, there's this ratio of 1 mile to 5,280 feet. We need to have the unit again that is given on the bottom and the unit that we want on top. We multiply this 23.6 times 1 divided by 5,280. We come up with this very, very small number, 0.0044697. We need to have three significant figures. There's three significant figures here. we need to have 3 significant figures in our answer. If you look at it, there's first significant figure, second significant figure, third significant figure. We'll look to the number to the right. It's greater than 5. This 6 becomes the 7. Same thing for the next one, kilogram to pounds. This is in mass, in the mass unit conversions. The way that you shortcut, like, so all of this relation are given to you, but be efficient by knowing what units you're working with. Are you talking about length, mass, volume, or temperature? Okay, so again, kilograms, the unit that's given has to be on the bottom. The unit that we want is on top. Multiply these two numbers divided by 1. Here's the answer. And obviously, there's 3 significant figures here. Again, this is in your exam reference sheet, so this does not take part into determining the significant figures. We need to round to 3 significant figures again. 1 significant figure, 2 significant figure, 3 significant figures. We'll look at the number to the right. It's less than 5. This number remains the same, and we have that. And again, as you can see also, the units cancel in both of this example. Meters to mile. Now this is a little bit more difficult. The meters to mile requires you to do 2 steps. But again, those ratios are given to you. So the first thing is, and there is not one proper way of doing this as long as you use the proper units, as long as you come up with the right number at the end. So I decided to convert meters into yards first. You could also have changed meters into feet first, but that is, again, this is neither here nor there. So you took 2.2 meters times, again, we're trying to eliminate the meters and we're trying to come up with yards. So that, now, do we have the unit that we want at this part? The answer is no, because we want to go to mile. So we multiply this by another relationship, and again, this yard, now since you have eliminated the meter, now you have yards on the numerator, you need to use a relationship that has yards on the bottom, and if possible, miles on top. And that is where this relationship comes from. And this yards on this numerator cancels this yard on the denominator on the succeeding ratio. And as you can see, what unit do you have left? We have miles. So if we do 2.2 times 1.0936 divided by 1 times 1 divided by 1,760, we have this number. Again, we need 2 significant figures. Again, this is a ratio on your exam reference sheet. This is a ratio on your exam reference sheet. Does not take part into considering significant digits. We only need 2. So this is all significant figures is normally based on what's given to you. 2.2 meters. So we need to have 2 significant figures for answer. Not significant, not significant, not significant. First significant figure, second significant figure. We'll look to the number to the right. It's greater than 5. This 3 turns into a 4. Similarly, gallons to liter. This is volume. We again, unit on top here, unit on the bottom there, unit that we want on top on the next one. Multiply 5 times 3.7856 divided by 1. Always go through this process. This is the answer, and obviously we need, how many do we need? We need 3 significant figures. Okay, and the reason why we need 3 significant figures is this is actually, if I'm going to move this around, it's actually 15, I believe. Okay, and what happens is if you multiply those 2 things together, you actually have 170.352, and you need 3 significant figures. Here's a problem. First significant figure, second significant figure, third significant figure. Number to the right is less than 5, correct? So we could write this down as 170. The problem with 170 is this trailing 0 is not significant. How do we make this significant? Well, you can put a dot there. We can put a decimal there, but that just looks odd. And if you put a decimal, you need to put a 0 on the other side of the decimal, correct? So the best way that you can do is, this is when you apply exponential notation or scientific notation. So we write this as exponential notation. We move the decimal point 2 times. This number is bigger than 1. So that is why it has a positive exponent. And we move the decimal point twice to the second. 1.70 times 10 to the 10 times 10 to the 2 liters, which is, now this has 3 significant figures, and again 3 significant figures in the next sample. Ounce to kilograms, so this is mass again, so it's similar to this. Again, unit, this is multiple steps. You want the unit that's given to you and the denominator in the next one. We end with pounds at this point, so we are not yet to kilograms. So we need to set up another ratio in which the pounds cancel and we have kilograms, because that is what's required. We do 36 times 1 divided by 16 times 1 divided by 2.205. This is a whole cluster of numbers, but we only need 2 significant figures. First significant figure, second significant figure, there's a decimal, thank goodness. 1.0 kilograms, there's 2 significant figures. All right, so that is the, in this case, the English to metric previously and metric to metric, or in this case, I'm sorry, English to English, English to metric. Now we can also convert units between the metric systems. The good thing about the metric system is a very straightforward, in this case, relationships. So I want you to read through this. So, and in fact, I might have to show you the next one. So here's the metric system, in this case, prefixes and relationship that's shown to you in your exam reference sheet, page 7 again. What happens is you can move up and down. So if I'm going from deca to exa, exa to nano, you could move between these units all you want. The whole difference, folks, is, and I shouldn't say folks because some of you don't like that, is every single step that you cross to go to a unit is a tenfold difference. So if I'm going to convert from kilo to deca is, you don't count where you're starting from. So kilo to deca is 1, 2 steps, 2 tenfold difference is 100, 3 tenfold difference is 1,000, 5, okay, 5 unit difference is, in this case, 100,000, because that's 5 zeros. So just the 5-fold difference is just 1 followed by how many steps you have. When you go down, you're multiplying but that fold difference. So if I'm going from kilo to deca, since I'm moving 2 spots, I'm multiplying by 100, because 10, 100. If I'm going from deca to kilo, I'm also doing 2 steps. It's going to be dividing by 100. We should do an example here. So this is meters into kilometers. Meter is in this base unit and we're going to kilometers. So we're starting at this dark blue line. So we're going to do not count where you're starting from. You're going to go 1, 2, 3. So there's 3-fold difference. 3-fold difference means 1 followed by 3 zeros. And since we're going up, we're going to be dividing by 1,000. Here we go. We write down the ratios. This units cancels. This is unit cancellation or dimensional analysis again. 3 significant figures. Your answer has to have 3 significant figures. Okay? So in this case, we were going from meters, the base unit, the dark blue line, to kilometers, which requires me to move 3 steps. 3 steps means 3 zeros. And the reason why I'm dividing is if you go up, you divide by the number of zeros. If you go down, you're multiplying by the number of zeros. Here we go, a different example, kiloliters into milliliters. Okay, kiloliters is right here, and we're going to milliliters, which is right here. So you don't count where you're starting from. So you go 1, 2, count the dark blue line, 3, 4, 5, 6. There's 6-fold difference between kiloliter and milliliter. That means 1 followed by 6 zeros. The question is, am I multiplying or dividing by 1,000,000? The answer is, since we're going down, we are multiplying by 1,000,000, and this is what you get. Okay, so again, the reason why we are multiplying by 1,000,000 is we're going down. If we were going up by 1,000,000, we would be dividing by 1,000,000. Centigrams into kilograms. So here's centi, here's kilo. So count steps. 1, 2, 3, 4, 5. 5-fold difference divided by 5 zeros, 1 followed by 5 zeros, and that's actually how you get those numbers. So be familiar with converting between English to metric, English to English, and between the metric systems.